Hello and welcome to another Solana tutorial. Today we're gonna talk about the new web3.js, which is the JavaScript library of Solana, that contains all the basic functionality like building transaction, connecting to RPCs, all that stuff. All that good stuff. And there's a new version. Well, or there will be a new version. There is a new version in development. So today I want to have a look at that. I'm not gonna do a deep dive, more like a surf on the Web3. Because, it's still in active development, so things might change. So I don't see the point of going through it in detail right now. I just want to put it on your radar that this thing exists, because you might not know that. And if I wouldn't surround myself with Solana devs and go to hacker houses and stuff, then I would also not even be aware of that, because it's not talked about much yet. Because again, still in development. So yeah, my goal for today is just to let you know that this exists and have a look at it myself, because I didn't do that yet until today. So in this short little video, I just want to give you an introduction to the Web3.js version 2. And we're gonna do a deep dive at some point in the future when it's officially released. Okay, let's get started. Here we are at the Solana Labs GitHub, and the Web3.js used to be in Solana, but they've moved it. It used to be here under Web3.js, but they have moved it to its own repo now at Solana Labs, Solana Web3.js. This is where it lives now. And this is the old and the new version. Both of them live in here. If you have a look at the branches, this is actively being worked on by Joe and Loris, who is also the guy who did a lot of the SDKs of Metaplex. Loris is working for Labs now. So this gotta be good. But yeah, how do I check for versions? Tags, there. So we can check out the individual versions here. And basically everything version 1 point something is still the Web3.js that we know and have always worked with. And then version 2 will be the new one. So that's the old one, the library legacy. And then library, this will be the new one. So here, that's the new one. The Solana JavaScript SDK. That's what we're talking about. The Web3.js is the JavaScript SDK. And it's used to interact with accounts and programs on the Solana network through the Solana JSON RPC API. And this one is experimental. So the library, the version 2, this is experimental and should not yet be used for production, because things might change without the warning and it might not be fully stable. So they better say use this one. The regular Solana Web3.js, the version 1 point something that we can also find in the library legacy. Here, this one, that's the regular Solana JavaScript SDK that we could install with npm-i Solana Web3.js, which we've always done. This is what we've always been working with. This is version 178.5 right now. And today we want to have a look at version 2.00, experimental something. So it's not yet released, but this is what's gonna come as version 2.0 eventually. And we could now either download it from Git and work with that, or we can also install it through npm with the Web3.js at experimental. This is the npm package that allows us to get this thing in experimental mode, so in version 2. Before we do that, let's have a look at the README. What else does it say? There are 3 main use cases for this SDK. First of which is interacting with RPCs. So building the correct JSON string that we then send to the RPC. So we can call JavaScript methods and don't have to know the exact JSON format that we require, and don't have to send the HTTP request manually. That's all done by the SDK, wrapped in some handy functions. Second use case, transactions. So building transactions and sending transactions. Again, sending transactions will then also go through this RPC infrastructure. And a third one, keys. So all the cryptographic stuff right? Creating a new key pair and working with file system wallets. This sort of stuff is also neatly handled with the JavaScript SDK. And yes, we know this. We've done this. There are examples. Create Solana RPC. Yeah, that's what we know from the connection object. And so things might change. And again, I will have a closer look at all of that, or some of that, once it's actually officially released and it doesn't change anymore, because I don't see the point of making a video and then it's going to change and then it's just going to be confused. So for now, I just want to say, yeah, this is what's currently in development and this is what it might look like. They have something like a base 58 encoded address, which is essentially a string. And then I can say definite RPC get balance. So again, that's what we used to do with a connection. And now we have this RPC object that might just be more flexible. The transactions might be unimplemented or the docs are not up to date. Who knows? I did see that there is a bunch of transaction stuff in transactions. So there is a bunch of stuff. There definitely is a bunch of stuff implemented. But yeah, point of this is it's just gonna look a bit different to what we're used to. And an example for keys, public keys in the form of base 58 encoded strings. So hopefully it's gonna make the base 58 encoding and decoding a bit easier, because for now we always had to use an external library that does that stuff. Maybe we have something in Web3 now. We do have an assert is base 58 encoded address. So if it's a valid public key, and then again, RPC get balance send. But yeah, let's not look at documentation. Let's look at the actual thing. Do I want to get it from GitHub or do I want to just download whatever is on NPM at the moment? I think I'm going to get the NPM package. I imagine it to be maybe a bit more stable. It might not be the most up-to-date version, but even the currently most up-to-date version is not the most up-to-date version when you are going to watch this video. So it doesn't really matter. Let's open Visual Studio. And we're going to make a TypeScript file because really it's a TypeScript library and not just a JavaScript library. And to get us this library, we just type npm install Solana web3.js experimental. Let's see if I can install that. Bunch of warnings. Resolve dependency tree, undefined at undefined. Incorrect and potentially broken dependency resolution. Okay, we are just gonna accept broken dependencies because we're not really gonna use it yet anyway. We just want to have a look at it. Oh no, I removed 4 packages. I hope I didn't destroy the other version now, but whatever. So we've installed that, great, with 0 vulnerabilities. And now we can import from Solana web3.js. Do I now need to say experimental? Or did it overwrite that? Probably overwrote that. Let's see. Let's see what we have in here. We don't have stuff like my connection anymore. Not even my public key that I'm used to is in here anymore. So we'll have to basically learn all of this anew. But maybe while we're here, talk about why did they do this in the first place? They just change a bunch of stuff that we all have to update our scripts? Why? From what I've heard, they built this new version, the version 2, to have fewer dependencies and therefore make the entire library way smaller. Because apparently it was just using a lot of dependencies and therefore being super big. And I think that's the main reason why we changed so much, or they changed so much. And really, I don't know. I would have to talk to the devs about that. But from their attitude towards it, I judged that this is a pretty cool thing. They were pretty excited when talking about it. I mean, I didn't listen much, but just when passing by, I heard them talk about the new web3.js and all the cool things it does. So eventually we're gonna figure out what that can do and why it's so much better. For now, I just think it has less dependencies, therefore it's smaller, therefore it's more easily usable everywhere. Could I test that already? Yeah, I would really like to have them side by side. Hold on, can I do that? Okay, so what I did now was to get my node modules locally, like in that very folder. Yes, now I have my connection here. This one is the V1 point something. And interestingly, we can already see here that it has a bunch more dependencies. Like, look how many dependencies there are. For instance, the BS58, a base 58 library. Whereas if I install the Web3 experimental, then I don't have that many dependencies here. Yes, I still have a few. Metabrex Foundation, Umi, interesting, okay. Some fast stable stringify, node fetch, very helpful. I don't know what that is, also not what that is, but yeah, it's not that many packages. WebSocket library, okay. So yeah, compared to this, much nicer. Let's see this in actual like file sizes. Guess I need to do that via Explorer. That is the size of the legacy one. To compare, this is of the V2. So we have 4 megabytes versus 25, which is a significant reduction in dependencies. Pretty cool. Cool. Now we also confirmed that. Perfect. And we can work with both our legacy here in this, and more importantly, the experimental here in this one. Oh no, is that also now the other version again? Yeah, okay, now it has the correct ones, the one from the... And here? Yeah, okay, cool. So I had to open 2 instances of Visual Studio such that they have the right TypeScript libraries here as well. So here we have the legacy stuff, and here we have the experimental V2 stuff. So what do we want to have a look at? Again, I don't want to do a deep dive here today. I just want to check it out. Just do some simple stuff and then call it a day. Something like create Solana RPC sounds like I want to do it. So yeah, should we just set ourselves the goal to send a simple transaction with this new web3.js? I mean, that would be a good goal, no? In Legacy, I would know how to do it. In Legacy, it would be quite simple. There's even a get cluster API URL for DevNet, and then system program transfer, get a key pair, airdrop 1 sol, and then I just transfer from my key pair to some other random key pair 0.1 sol, and then send and confirm transaction. That's fairly quickly written because I've done it 100 times. I just sent some sol. Let's actually see if that would work. I mean, the issue here is the request airdrop. If that doesn't work, then let's just see. Or maybe we just request, maybe that makes a difference, I don't know. Let's see. This one will give me the, big int failed to load bindings, this annoying error, which I hope that the new one doesn't. And then send transaction, attempt to debit an account with no record of a prior credit. Damn it. Okay, fine. We just skip pre-flight, so it submits the transaction anyway. And if the airdrop worked, then it should accept it. And Explorer on DevNet. Yep, cool. That actually worked. Nice. I sent something from here after getting my airdrop to here. Perfect. Now I want to do the same thing with the new experimental web3.js TypeScript SDK. This is gonna get interesting because I have no idea how any of that works, but let's see how intuitive it is. And maybe not even all of the functionality is there yet. I don't know. We're gonna find out. We're just gonna play around with it. See, that's what I like to do. I just like to play around with the libraries such that I learn. So we create a Solana RPC. What does that need? A config, transport, and what is that? IRPC transport gives me an RPC with Solana RPC methods. Loading, loading, loading. You know what? I saw that in the docs. Might as well check it out. Create Solana RPC transport, DevNet transport, and DevNet transport was a create default RPC transport from DevNet. So here we have the URL. This gives me the IRPC transport, so the interface for RPC transport, and that we can then put in here. Seems a bit complicated, admittedly, but just because I didn't get used to it, there's probably a very nice reason why they do it like that I just don't know yet. So we just gotta play around with it. That's always the case, right? First you gotta figure out how it actually works, and then only later you actually understand what's happening here. That happens to me so many times with so many things. So in the beginning, I just try to accept it as it is and not judge it too much. So then we have this create Solana RPC that gives me back a RPC method. So I'll just call this my RPC then, which is now a RPC methods of Solana RPC methods. Great. So with this RPC, we can do the following things. Nothing. Keeps loading. I mean, the color of this, something is weird here. Feels a bit stuck right now. I Keeps loading. Something is broken. I can't work like this. Well, let's just copy that part and see if I get that to work. So from our RPC, we get balance. Get the balance of the system program. This thing we gotta import. Yeah, something is broken. I don't like it. Let's see if I could execute that. Does it do anything or does it not do anything? That is the question. Will it break or will it execute? Because it takes weirdly long to start. Like uncomfortably long. I mean, yes, my computer is recording and therefore pretty slow, but still, even the legacy thing was way quicker. So I guess I do have some issues with TypeScript. Oh, there we go. It took very, very long, but here we are. So, balance of system program account in Lamberts, and then we get the entire thing back. So the send gives us a promise for read-only context with slot and value, and that's what we see here. We get the context with a slot and the value 1n. So 1 Lampert is in the system program, which we know is the case because the system program as a read-only account just has 1 Lampert. And we could check that account that we just earlier sent something to instead of the system program. Wow, can I? This is so weird. Something is really broken. And then from this, I basically just want a dot value. So yeah, for some reason, this is super, super slow and I can't really pinpoint why. This thing just works relatively fluently. Oh, but also, did you see? This one doesn't give me the error with the big int failed to load bindings. So we're not using this library anymore. Yes, I don't always get that annoying message. Looking forward to this version 2 of web3.js. But yeah, it's a bit weird. Something is still not optimized or something because it's super slow. And you really feel that if your computer is like slow as well. I mean, I couldn't develop like this. Like this is, if you have to wait more than a few seconds for something to execute, then just no. And then you get an error. Oh, yeah, annoying. I mean, it works, but it doesn't work well. Like, not for me, not in this setup. But I think that's because of my NPM setup. I think something is weird here. Because the whole of Visual Studio is essentially laggy. Super goddamn slow. Something is weird. And it works. I'm hoping that in the future this will get better. So cool, we can look at the Lamberts of that account. So 0.1 sol is on this account, perfect. What else can we do? We want to build a transaction. Create transaction. I cannot work like this. So annoying. I just want you to autocomplete. And then tell me what you need. Autocomplete and tell me what you need. I wonder what is messing with it so much. Is it that part? Something with that messes with it because now it's faster, I think. So there's something with those types, but no, I will not analyze it. Anyway, so you need a version 0. Let's make a version transaction. This will give me a v0 transaction. Perfect. So this is my v0 transaction now. What can I do with this v0 transaction? I can put in instructions because it doesn't have any setters or anything. It just literally... That's probably not the way how you should do it, but I'm gonna build myself instructions here. Okay, but how do I get an instruction? Let's see. What else have you got for instruction? Oh, append transaction instruction. Prepend transaction instruction. That's probably how you do it. So instead of doing this, you append transaction instruction and instruction to a transaction. Cool. Then we just need to get our instruction. How do we do that? An instruction consists of accounts, data, and program address. So they basically just changed the names. It's not keys anymore, but accounts, which makes more sense. It's more the vocabulary that I would use as well. I was very confused why they call it keys in the first place. But yeah, and then program address and not program ID because it's an address. Similar, but just called a bit different. I guess I'm just gonna build myself it manually until I figure out how to do it nicer. I'm gonna build myself an instruction with program address as we had before the system program. And that requires to be a base 58 encoded address. So I just say S base 58 encoded address. Easy. Then my accounts. So now I need to know, because now we're building it manually. Now we're building this transaction manually because I don't know if there is something like that. I didn't find it yet. Probably will come in the future or something like that. I don't know. But anyway, it's always good practice to build that by yourself. So the accounts are these two. From where to where do we send? Oh, and then we of course need a key pair as well. Generate key pair. Key pair. Generate key pair. Promise to a crypto key pair. Perfect. Await this, then we should have a crypto key pair. And the crypto key pair should have a private and a public key. Perfect. So from the public key, oh wait, accounts need to be account metas. So first of all, we need a list. And secondly, each of those will have an address. And then, oh, this is very manual though now. This is almost too manual now. So just needs address and role. Okay. So normal account meta just needs address and role. So address and my role. This is probably signer, writable signer, or read only. Something like that. The role is an account role. And what the hell is an account role? Haha, as I said, writable signer, read-only signer, writable or read-only. So we don't have the two booleans anymore as we had in legacy. Let me show you how that worked in legacy. When we were building a manual instruction, transaction instruction for the keys is account meta. So here we had several account metas. And for each account meta, we had the public key. So that's the address. And then we had the two booleans is signer and is writable. And now instead of this, we have this role, which can be any of the combinations, right? Writable signer, read-only signer, writable or read-only. That's just a combination of two booleans. So we want a writable signer. I'm gonna say role is writable signer, which I will import. Cannot import. So where is it stored? In account role. So let's see, account role dot writable signer. Perfect. And what do you complain with the address? Oh, that needs to be a base 58 encoded address. And the public key, what is this type? I don't think that will work because it's not a string. How do I get the, oh, that's probably something in there. Get address from public key. Haha, get address from public key. It's cool. I like to play around with this stuff. Oh, still not. Oh, it's a promise. I need to await this. Oh, wow. This is not cool, but it will do. Why is this async? Anyway, not questioning it. Don't question stuff, just accept it. Okay. Okay, so we have system program and the first account is the sender. Then the second account, so we do this thing one more time for another account meta. This time just writable, but not a signer. And we send to, I don't know, my address again, because I can. Might as well send to that address again. And then the data that we're still missing is the instruction data for the system program transfer. So it's the discriminator for the transfer instruction and then the amount of Lamberts I want to send. So do I know that by heart? No, but I can look at this thing and then I just look at the raw instruction data, which will tell me that the first 4 bytes are for the instruction discriminator and 2 is for send, and then this is the number of Lamberts to send. So this is 0.01. This number in hex looks like this. And little endian, by the way. Okay, so let's put in the data as well. Data needs to be in which format? A uint8 array. So I can work with buffers again, and then I just do it to uint8. How many? 4 plus 8 is 12 bytes. and data 32 little endian 2, and then data write big int 64 little endian at offset 4, and the value is 0.01 sol again. Why not? Data, does it take that directly? Can it convert that? We'll see. So that is then my instruction that I append to this transaction. Does that gives me v0 transaction? So I don't know if I need to do that, but to be safe, actually no, I want to learn. I want to see if that appends it into the transaction or if I would need to store that. So let's just try and send this transaction somehow. I mean, that should be on the RPC, but I don't want to uncomment this because then it gets unstable again. But okay, fine, let's do it. Yeah, something is weird with this create Solana RPC. As soon as I have that, it's stuck. Maybe there are circular dependencies or some weird stuff. I don't know, I have no idea. And I'm assuming they're gonna fix it at some point. Can't even go to definition of this one. Let's check it out on GitHub. RPC methods. Haha, here are all of the methods. Get account info, get request airdrop, and then send transaction. Takes a base64 encoded wire transaction and the config. Send transaction. I know that you don't give me types. Somehow from this v0 and to a base64 wire transaction. There we go. We have a get base64 encoded wire transaction. And it needs a transaction. Transaction which is a compilable transaction. This is fun. Let's see, is my TX a compilable transaction? No. Okay. What would make it a compilable transaction? I mean, I need to sign it before as well. So this is interesting just to play around with it. Promise for a T transaction or a transaction with signatures. My key pair and my transaction. Nope, v0 transaction is not assignable to compilable transaction. So still I need a compilable transaction. You also still give me a v0. How do I get a compilable transaction? Transaction with fee payer. Transaction with signatures. Fully signed transaction. There's so many interfaces, it's fun. Okay, but there must be functions that allow me to do this, no? Set transaction fee payer. So all of those things. The set transaction fee payer, set transaction lifetime using block hash, and set, no, we don't want to use a durable nonce. Let's do those. So before we sign it, we also set transaction fee payer again here like this, and it will give me a transaction with fee payer. So const tx with fee payer is this one. And can I sign this already? Nope. I also need to set transaction lifetime using block hash. So the block hash probably get from the RPC, and this is where it gets complicated again. Back to my RPC methods. Last block hash. Get latest block hash. Returns the latest block hash. Await probably. And this is, it doesn't have the types for this. Now it's stuck. Yeah, as soon as I get this RPC out, it's just stuck. I guess I can lock this block hash, which is gonna be an RPC response. So we'll see what it does. We wanted to set the lifetime. You need a block hash and the transaction with signatures or a durable nonce transaction. And then I get a transaction with block hash lifetime. This is so weird. Oh shit, no key generation implementation could be found. Can't even create myself a key. Do I put something in here? Oh, I can also do it sync. Ah, and then I need to... Okay, which curve are we on? This one, right? Yeah, okay. That's not what I want. That's too cryptographic. I just want the public key address. Ah! We will get there. I mean, I thought this was a short video, and maybe it will be because I edited all that out, but hey, that looks good. We just get an object and whatever, and we could read the balance. So we got there. Oh, I need to .send because this thing will just create the RPC method and then send will give me the result. So that's what I want to do. Whatever that gives me, I'll then try to put in here. with a floor price, I mean a fee pair, which will then give me my unsigned transaction. Ah, look, that looks better. And then I can sign this, and then the signed transaction. Nope, still not. But we have a fee pair, instructions, lifetime constraint. Oh wait, is this all a promise? This does give me a promise. So this I need to await. Haha. But then, haha, this is how you need to do it. See, all of those things you need to do, and then you get there. Nice. But yeah, there we were at no key generation implementation found. Let's ignore that. So I guess I need some packages to create them or something. Oh man, I would really like to get it to work. Assert key generation is available. No key generation implementation could be found. Install and import Solana web crypto polyfill. But for this one, it doesn't give me a definition. Web crypto. You went over this. Maybe that was it. Maybe I just had to add this web crypto ED25519 polyfill. Wait, no, but then I'm still at the unable to compile. As long as I'm unable to compile, obviously we don't get to that error. Yeah, and then if we compile, then at runtime it will still throw me that error here probably. Oh, so annoying. All I do all day is just wait for this thing to start. Let's do what we always do. If we're lost, complain on Twitter. But pretending that we would have a public key and a key pair to sign, then I could encode my transaction like this. And then I could say RPC send transaction, this encoded transaction. And we again don't know the types of this. Takes the transaction and the config, which I can leave free. Okay, cool. So this should give me a send transaction response, which should be a base 58 encoded transaction signature. Oh yeah, dot send probably log the signature. So I would expect that this would do the same thing as the code that I wrote in the legacy. Just that I can't get myself a key pair. Man, I'm getting tired. This is taking way too long again. Just wanted a quick little video. Maybe I'm doing too complicated things. Sending a transaction, too complicated. No, creating a private key, that's too complicated. Don't know why the global.crypto just doesn't exist. I don't know how to get it into NPM, into Node. Oh, maybe I just need to import that as well. Wait, what now? Number is not assignable to big int. It's not assignable to Lambert's unsafe beyond. The types. The types, man. I hate this. I always need to uncomment this, otherwise everything is broken. But let's see what importing this does. Maybe if I import that, and not just install it, but also import it, then it might actually, maybe, hopefully do something. It's not assignable to type read-only brand unique symbol. Man, how do I get a okay. What? But maybe I'm starting to understand this. Maybe this whole thing is so modular that I have to import everything individually. So if I want to work with Lamberts, I need to import that RPC core. There is more in Solana. So that is pretty modular. Hold on. Can I import not from Solana Web3, but from Solana addresses or something? Or RPC core? Ah! I'm going crazy. This is so stupid. Okay, yes I can. Look, from addresses and from RPC core, I can import the Lambert's unsafe beyond. And how do I get Lambert's? I have a assert is Lambert's. I'm doing so many things at the same time. Playing with this, trying to get this to work. Okay, one more time with the Lambert's. Otherwise we ignore that. This is taking so long. That's why we don't use this in production yet. It's just not there yet, or I'm just not there yet. Whoa! But it did something. we had too many requests, but it did something. Probably this. So first I printed my public key, and then I requested, and then what else did I print? Oh, this was my promise. Oh, I need to, so apparently I do need to await this. And then I got too many requests. Okay, try that again. Hey, but that looks good. We created a key pair and we got the block hash. Yeah, finally, we're getting somewhere. Okay, so then we just need to get the actual value of this. So let's forget about that. And he's playing again. So just value YOLO. Let's go. And then we sign the transaction and do this. And we did request. Ah, this looks amazing. Okay. It looks like it actually works. Let's also send the transaction. We first set the fee payer. Then we set the lifetime using a block hash, which we read like this. Then we sign the entire transaction because we now have a key pair, score. And then we encode that, and the encoded thing we send and get ourselves a signature. This would be amazing if that would actually work now, because then I could be on time for my evening program. Otherwise, I will skip my evening program until that works, because I got priorities. Ah, such long waiting times. But it's okay if this is gonna work now, and then I won't wait anymore. Then I won't wait any longer, because this is totally gonna work. Come on. It is totally gonna... What? Too many requests? You for real? You... How did I make too many requests? I need another RPC. Helios. Help me out here. So ridiculous how long I wait for this. I don't know what my TypeScript does in the background. Maybe I should have run it as JavaScript. Huh? That's my public key. Then I probably forgot to await this one. Invalid base 58 encoding. But I don't know where that comes from. Let's look on change. So at least the airdrop worked. So I can airdrop myself something with this new web3.js. That's already something. But then I'm messing up something else. What is it trying to pass? My transaction, but send transaction, but that is my base config, send transaction config. This is so weird. Here I have a base 64 encoded wire transaction, and the encoding, and there it says encoding base 58, and there it says encoding base 64 and encoding base 58. So they have different defaults, and since it's a base, maybe that's my issue. Hold on. Maybe I just need to once again tell you here for sure. Well, I would expect it to go like encoding base 64. Let's try that. Last try. If that doesn't work, I'm gonna give up. Come on. Come on. You can do it. You can do it. You can do it. Yes, we have an address. Yes, we have a block hash and an account not found error. Transaction simulation failed. Attempt to debit an account. But that's okay. That's okay because you're just behind. I just want to skip pre-flight, but I don't know how. So instead of skipping pre-flight, I'm just gonna await a new promise for 30 seconds. Because I don't know how to skip pre-flight checks. But yeah, I don't want to figure it out. I'll just wait. Okay, but now, one last time. Because it did work. It just didn't manage to send because the RPC didn't have the correct state. Because I just got the airdrop. Yada, yada, yada. We can do this. And we're not even waiting the 30 seconds yet. We're still waiting for that entire thing to just start up. Man, am I annoyed by that. Clearly doing something wrong. Okay, so now we're waiting those 30 seconds. Now we got the airdrop and our block hash. Oh shit, maybe I should have gotten the block hash later. But 30 seconds should still be enough for a valid block hash. We should still be fine. We got almost 2 minutes. Yeah, let's wait. Just to give the RPC some time, such that it doesn't kill me in pre-flight. And then we got a signature! Look at that, look at that. Ah, I love it. I love it. We got a signature. Check this out. We actually did a transaction that does nothing because there are no instructions in this transaction. Nice. Which also means we learned another thing. Because I tried this and apparently, yes, you need to say transaction with instruction and then, wow, it's completely broken. And then put the transaction with instruction here. And then that should also work. So, to recap, this whole new Solana web3.js experimental thing is very different to what we're used to in the legacy way where we have our key pairs and connections and stuff. It all looks very different, but after playing around with it a little, I managed to, you know, create myself a transaction and actually send it. The main issue I had was that my version of Node didn't have the crypto module or whatever. Steven explained it to me. It will work in Node 17 plus. So apparently my Node version is not high enough. Yeah, I'm on 16 something. So I would need to update my Node version or use this polyfill, which is not super secure. Don't use this for production, blah, 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 whatever. But don't use the entire thing for production yet anyway. So yeah, that was the one thing that I struggled with a lot. But then it's somewhat self-explanatory. I mean, you have to mess with types a lot. But I mean, this could be really cool, actually, changing to this. It's more lightweight and we just gotta get used to a new SDK because things are just in active development and stuff changes. With that said, thank you for watching this video. I hope it's not as long as I needed to record this, because god damn, with waiting so long, it's really frustrating sometimes. But I guess that's just the dependency something. We'll figure it out. Maybe it's just my setup. I don't know. But yeah, that's the experimental Web3 version. And look at that. LFG. When we now actually add the instruction as well, then we actually do a transfer and that actually worked. Yes! Score! We airdropped ourselves something and we sent something to this address. Nice! We managed to do an actual system program transfer with the new web3.js. Isn't that freaking amazing? I think that's freaking amazing, and you can tell me otherwise in the comments. Or just try it out yourself. Or not. I mean, really, I wanted to bring this to your attention, that this is a thing that is being developed. You don't need to do anything with it just yet, but eventually we want to change to this version and the old one will get deprecated at one point. We're not at this point though. We're still working with the legacy one. And all should be good. I would not even recommend switching to this one, even though you know it's gonna come. But because things still change and might be unstable and whatever, I would not recommend using it yet. So yeah, it's just fun playing around with the new tech, such that you're at the bleeding edge, where it's super annoying to work with it, but also super rewarding sometimes. Now, if you excuse me, I gotta go because I'm late, because that took forever. And you can go watch those videos, like and subscribe, and I will see you in the next video where we talk about something else. And then eventually we're gonna talk about this again once it's officially released. Till then, bye bye.